In the brutal arithmetic of World War II, the Battle of the Atlantic was a game of numbers that Great Britain was losing. By the autumn of 1942, German U-boats were strangling the British Isles. In November alone, roughly 800,000 tons of Allied shipping were sent to the bottom of the ocean. The Royal Air Force's Coastal Command was flying hundreds of sorties, hunting the submarines that were starving their country. Thanks to improving radar, they were finding them. But there was a catastrophic system error. They couldn't actually kill them. Aircraft after aircraft would spot a surfaced U-boat, dive out of the clouds, and drop their bombs. And the U-boats would simply survive. The standard aerial bombs and heavy depth charges were incredibly inaccurate. To rupture a U-boat's pressure hull, a lethal charge had to detonate within roughly 6 meters of the submarine. When dropped from a fast-moving plane onto a thin, moving target, achieving that level of precision was nearly impossible. Internal statistics from 1942 revealed a horrifying truth. Only 1 in every 100 attacks resulted in a confirmed sinking. The RAF needed a cheat code. They needed a weapon that didn't require perfect aim, but instead covered the geometry of the problem with brute force. They found their answer in a weapon so absurdly simple, yet so brutally effective, that when the first damage reports reached German Naval Intelligence, they concluded they were fighting something that couldn't possibly be a physical weapon at all. This is the story of the Mark I Anti-Submarine Bomb Cluster, known to the men who flew with it simply as the chain bomb. The solution didn't come from a massive billion-dollar research program. It came from the mind of Group Captain George Stainforth, a former world airspeed record holder working at the Royal Aircraft Establishment. Stainforth looked at the problem of hitting a long, narrow submarine and asked a radically simple question. What if we stop trying to drop one perfect bomb and instead drop a continuous line of explosions directly across the submarine's path? He designed a weapon that looked like a terrifying steel necklace. It was a series of cylindrical explosive units, each roughly the size of a large loaf of bread, and packed with 15 kilograms of high explosives. These units were connected by steel links measuring about 30 centimeters each. When deployed from a low-flying aircraft, between 50 and 150 feet, the entire assembly stretched out over the water. A full 12-unit cluster covered nearly the entire beam width of a standard German Type 7 U-boat in a single pass. The brilliance of the chain bomb was its detonation mechanism. The charges were pressure-triggered, set to fire at a depth of between 1 and 4 meters. The charges didn't actually need to hit the submarine. They simply needed to sink alongside it. When multiple charges detonated simultaneously in close proximity to the hull, the overlapping pressure waves were catastrophically lethal. When the chain bomb entered operational service in late 1942, it was kept as a closely guarded secret. The RAF knew that if the Germans understood how it worked, they would adapt their tactics. The results of this secret deployment were immediate and horrifying for the German Kriegsmarine. In the very first week of full squadron deployment, Coastal Command confirmed 4 U-boat sinkings attributed entirely to the chain bomb. For the German submariners on the receiving end, the experience was profoundly terrifying. Survivors described a sound like a blacksmith striking an anvil at speed, followed by a weapon that seemed to detonate around them, beneath them, and against them all at once, with no clear point of origin. German Naval Intelligence was baffled. Internal reports from the Kriegsmarine's technical division speculated wildly. Was it a new type of acoustic or magnetic mine dropped from the sky? One post-war recovered document described the phenomenon as a device of unknown type causing multiple simultaneous detonations without visible aerial delivery. To the exhausted, terrified U-boat crews, it felt like the British were using black magic. The American military tackled the same anti-submarine problem with high-tech solutions. They developed the FIDO acoustic homing torpedo, an incredibly sophisticated weapon that actively tracked its target. But the British chain bomb was philosophically distinct. Where the American torpedo cost vastly more per unit and required delicate maintenance, the chain bomb was rugged, cheap, and mechanically simple. It required no gyroscopes, no acoustic sensors, and no electrical connections. A ground crew could arm a complete cluster in under 10 minutes, and it could be fitted to almost any patrol aircraft without modification. While the exact production numbers remain partially classified, it's estimated that between 12,000 and 18,000 units were manufactured in the north of England. Its confirmed kill rate rivaled the highly sophisticated American homing torpedoes. The spring and summer of 1943 marked a decisive turning point in the Battle of the Atlantic. In May alone, the Allies sank 41 U-boats, prompting Admiral Karl Donitz to temporarily withdraw his forces from the North Atlantic, calling the losses catastrophic. Historians still debate whether the chain bomb was the primary cause of this reversal, or simply one of many factors, alongside improved radar and better convoy organization. However, the psychological impact is undeniable. The fear of this unpredictable, invisible weapon suppressed the U-boat crew's instinct to surface and recharge their batteries, making their patrols shorter, slower, and vastly more cautious. The chain bomb didn't just sink submarines, it deterred them. Today, you can see surviving examples of this weapon at the Royal Air Force Museum in London or the Fleet Air Arm Museum in Somerset. They are unspectacular objects, dull gray cylinders connected by steel links. Nothing about them screams high-tech, but the chain bomb represents the ultimate system override. It was an engineering solution that proved you don't always need the most complex, expensive technology to win a war. Sometimes, all you need is a stubborn group captain with a pencil who refuses to accept that a problem is unsolvable, and a necklace of steel that makes your enemy question reality itself. If the ingenious simplicity of the chain bomb changed how you view World War II engineering, hit that like button. It tells the algorithm that the unsung, forgotten weapons of history deserve to be remembered. Subscribe and turn on notifications so you never miss our deep dives into the archives. What do you think? Was the chain bomb more effective because of its psychological terror or its raw, explosive power? Let us know in the comments below.